Hello everyone, Dan here for Waygate Technologies with another installment in our series on the USM 100 portable flaw detector. So today we're going to take a look at AWS D1.1 sizing and evaluation. Okay, so first step, we're going to launch our app, and we'll go ahead and launch. So I've already gone ahead and set up the probe parameters and calibrated for delay and velocity on the IIW block, and I've checked my angle. So I'm going to go ahead and load those settings. So that is AWS set 2. And that gives me a basic setup. Let's pull in a DSC block quickly, and we can see there's our 1-inch and 5-inch echoes from that. So we're all set there. We're going to be looking at AWS D1.1. The AWS inspection uses particular probes and wedges. The wedges have this familiar snail shape to them. This is a 45-degree AWS wedge on a 2¼ megahertz 5/8 inch square benchmark probe. So this is one of the classic AWS probe and wedge combinations. So we'll go ahead and set things up for that. Now let's talk a little bit about AWS evaluation in general. So the AWS evaluation uses a result that is calculated called a class of flaw expressed in decibels, and that calculation comes from comparing the gain of an echo during inspection to the gain required to set an indication, a reference indication, to 50% screen height. It compares those two gains and also applies a correction factor for attenuation, material attenuation. So we talk about 4 parameters. Parameter A is the flaw gain. So that's the gain that would be required to get our echo for the signal under evaluation to 50% screen height. B, the parameter B, is our reference gain. How much gain did it take to set our reference indication to 50% screen height? C is our sound attenuation factor, and that is partially modeled on the probe, partially modeled on the attenuation of material, beam spread, and so on. As the indication goes deeper and deeper into the part, the sound path from the probe to the indication is longer and longer. We factor in some additional gain to make up for the loss of sound over the distance involved. Okay? So C is calculated as 0.079 dB per millimeter, and the measured sound path to our gate, minus 25.4 millimeters, is that's how C is calculated. Okay? And you take those 3 parameters, the gain for the current echo under evaluation, A, subtract the reference gain from that, and subtract the material attenuation correction from that, and that gives you a result in decibels that represents the class of the flaw. So we're going to walk through how to calibrate for this, and then we'll look at a couple of holes in a sample, a multiple hole sample, to give you an idea of how the evaluation works. Okay. So step 1, we're going to change things around a little bit. In past videos, we have looked at our Auto 80 feature, we call it. So we have the ability to set any indication to 80% screen height. With AWS D1.1, most of our recording of the reference and our evaluation is going to take place with respect to 50% screen height. So rather than going to 80, what we're going to do is going to open our gain menu, And if we look down here, we have auto XX amplitude. That's currently set to 80%. So we're just going to run that down to 50%. Let's use our scroll wheel since we don't have far to go. So we'll set that to 50%. And now when we peek up on our reflector and hit the automatic gain, it takes us to 50% rather than 80. Okay, so that's going to be very handy as we go through our calibration. All right, so let's go ahead and close our gain menu. Now, we are already on our evaluation panel. We've previously gone through and set the delay and velocity and angle and so on as we discussed. So we're on our evaluation panel. Let's open the evaluation menu. Here we see it's already selected the AWS D1.1. By default, that's going to be dB ref when you're going through your app from the beginning. So we're going to select AWS D1.1, and we'll go ahead and close that. And typically our calibration for AWS uses the 1/16 inch hole at 0.6 inches. Actually, it's a 60 thousandths hole at 0.6 inches. I believe that's 1.5 millimeters at 15, if I'm not mistaken. Okay, and we have our AWS probe and wedge. So we're going to go ahead and peek up on that indication. We have a lot of range selected here at the moment. Let's take our range down a little bit. Let's go to 3 inches of range. Okay, so we're going to go ahead and peek up on that hole, and we're going to hit the calibrate button. Now, you notice we got a B reference recorded successfully. We got that message. And up here in the upper right hand corner of the A scan, we now see 4 tiny readouts, A, B, C, and D. So as we discussed before, A is our live gain, or evaluating the echo and gate A, okay, in comparison to 50% screen height. So what gain would be required to get the signal in gate A to 50% screen height? And right now that's saying right around 46 dB, which makes sense because that's our currently selected gain, and we have about 50% screen height echo. Okay. Readout B is our reference amplitude. So when we hit our calibrate, what gain did it take to hold that indication at 50% screen height? Okay, so that was our recorded reference gain. C is our material attenuation compensation, and because we have less than an inch of sound path here, C is going to be 0. All right, anything under an inch, we're not adding any material attenuation correction in the equation. And D is our flaw class, which it is now saying is 0. Okay, so we have our gain. We're back on our calibrated hole, and that's giving us a class of 0. Okay, we're at essentially the same gain, and we're not doing any material attenuation correction. So now we're all calibrated. Now typically, once the calibration is done and you're ready to scan, most inspection procedures are going to call for you to increase the gain, often by 6 or 10 dB, to give you a scanning gain level. Helps you quickly find indications. So let's take a look. We're going to scroll up on our menu here a little bit, and we're going to change our dB step to 6, and we'll just keep that at 6 for the moment. And now if I increase my gain by 1 step, but I'm reaching around to the gain control in the back, increase it by 1 step, you see that my gain is expressed as 46, which was my reference gain, and I've added 6 dB to scan with. And the result of that is now I have an effective gain of 52 dB. Now I have a block here with 1/16 inch side drilled holes starting at 1/4 inch, 1/2 inch, 3/4 inch deep, 1 inch deep, 1 1/4. So we can compare some of these holes to what we recorded as our reference. So now as I'm scanning, there's my hole at 1/2 inch, and it's huge. So what I can do is peek up on that, and I can either take my scanning gain back out, but it's still rather large. Now as long as it's on screen, we're going to get an evaluation. So it's saying, the way I have it peeked up right now, my reference gain was 46. My A parameter, my scanning gain, is 42.5 right now, so I would only need 42.5 dB of gain to get that to 50%. So if I go back and hit my auto gain again, take it to 50%, that's taken me down 4.5 dB from where I calibrated, and I'm back to about 42. Okay, my material attenuation correction is still 0 because I'm still under an inch of sound path, and my class is now -4. So my D parameter, taking A minus B minus C equals D, is now -4. So the more negative the number, the larger the flaw is in comparison to the calibration. So more negative is a larger indication, larger reflector. Okay. So let's slide back here, peek up on the next indication. This one's at 3/4 of an inch deep and right about an inch of sound path. So we'll peek up, we'll hit our auto gain. That's 6 dB down. So I need 6 dB less at that distance. My class is now -5. Okay. Let's add a little bit of coupling here, and we'll look at some of these deeper indications, and we'll begin to see material attenuation correction come into play. So there I'm peaked up on the 1.25 inch. Hit auto 80. Now we see that our material attenuation correction was calculated as 2 dB. Our sound path distance is 1.75. So we have an 1.75 inches of sound path, and our material attenuation correction calculation for that gives us 2. Our gain is 42 again to accomplish getting this echo to 50% compared to our reference gain of 46. So 42.6 minus 46 minus 2, and we have a class of 5. Okay. Now one thing we can do, our two primary readings that we're most interested in here are the A reading and the D reading. So let's take our two big readings up here that right now are A%RA and dBRA. Not very useful readouts in this evaluation method. Let's instead choose, you notice when we open our readout selector, our choices are gate readings, AWS, now that AWS is our selected evaluation mode, and scan. So if we look at AWS, there are our 4 indications. So let's say we want to make that first readout our A indication, and we'll make the second readout our D rating. Okay. So now our 2 large readouts are appropriate for the AWS D1.1 method. And we'll back up here and peek up on our 1 inch deep echo. There's our 1. Go to auto gain, take it to 50%. Now we have our A amplitude in dB of 41.7. So it takes 41.7 dB of gain to get 50%. Compare that to our reference gain of 46, part B. Item C, our material attenuation correction for 1.4 inches of sound path is 1. So we subtract A minus B minus C equals D, and we come up with a -5 rating. Okay. So that is AWS D1.1 in its simplest form. We walked through how to calibrate and how to evaluate the use of scanning gain when we're rapidly moving. We can see the offset gain compared to our reference gain and our gain controls, and we looked at how to change the large readouts to be more appropriate to the AWS. Thank you for joining me. As always, if you have any questions, please reach out to remoteservice@bakerhughes.com, and we very much look forward to hearing from you. Thank you.